Hello AP Stats students, Mr. Hazelhurst here with your Chapter 13 introduction video. The first thing I want to do is wish you a happy spring break. The light's at the end of the tunnel for you seniors. We come back in only a few more weeks to go. But I am going to ask that you buckle down, stay focused, and let's finish this semester strong. Alright, what we're going to get into in Chapter 13 is taking the next step in statistical inference. So we've been comparing one population to a specific number. And now it's time to compare two populations to each other. So I think the best way to introduce this is through a little cartoon that's in your textbook. In this cartoon, as you can see, we've got the two ladies talking. I just read that the average woman is paid 75 cents to every dollar that men make. It's an outrage. In the second box, I'm the highest paid engineer in the company. The third box, that's impossible. The article says average women earn less. And suddenly the problem comes into focus. Well, in this cartoon, they illustrate a great example of what we're going to do here in Chapter 13. All right, we're going to compare two populations to each other. In the cartoon, they're comparing the average amount of money that a man makes to the average amount of money that a woman makes. Now, what makes this different from what we have been doing in Chapters 10, 11, and 12, is we're not comparing one population to a set number, but we're comparing one population, male salary, to another population, female salary. And that's what makes these situations known as two sample problems. All right, the situations where we're either comparing two populations or we're comparing two treatments. And this is the most common type of statistical inference that we do. And part of the reason why is you think of all the experiments that are run. In order to be a properly designed experiment, we have to have a control group and an experiment group. And so in those cases, if we're going to study the results of those and from a statistical inference process, we're going to use two pieces of data, all right, two treatments. And so again, we're dealing with one of those two sample problems. So that's what we want to take a look at here today, is just introduce you to these concepts. So when we talk about two sample problems, it's kind of boiling down to a few things. Again, the goal of inference is going to be to compare the responses of two treatments or to compare the characteristics of two questions. And we can really boil this down to two big questions. One, is there a difference between our populations? If they're asking, is there a difference, then we're talking about a significance test. We're trying to see, is there a statistically significant difference between one population or one treatment and another. Significance test like we dealt with in Chapters 11 and 12. If they ask what's the difference between these two populations, well, then we're talking about a confidence interval like we dealt with in Chapter 10. So in Chapter 13, we're going to deal with both significance tests and confidence intervals. And we can summarize all these together because they are so similar to what we've already done in Chapters 10, 11, and 12 that I think you'll pick up on these concepts pretty quickly. All right, now the key in order to make a two-sample problem work is that we have a separate sample from each treatment or each population. All right, and these responses from these two groups have to be independent of each other. Okay, so those are just some basic things that we want to keep in the back of our mind as we work through these problems. So let's take a look at the steps next. So in our inference toolbox, we're still going to deal with the same four steps: parameters, conditions, calculations, and our interpretation. And you can see here I've highlighted in yellow kind of where the changes occur within a two-sample problem as opposed to a one-sample problem. All right. So the first change is in the parameters. Right. When we define those parameters, we're not going to have one population to define, but we're going to have two populations to define. And so depending on whether we're dealing with means or proportions, that'll determine what we're dealing with. But you can see here we've got mu1 and mu2, or we're going to have p1 and p2, because again, we're dealing with two populations. Now that is also going to affect our hypothesis step, and we're going to look at that on the next slide. When we get to our conditions, the same idea behind the conditions apply. We still have to have a simple random sample. We still need to verify normality, and we still need to have independence. All right. The difference is now we're going to have to check those for both populations. So as we do the condition step, it's almost going to look like we do it twice. We'll do it once for population 1 and once for population 2. And the only way we can move forward is that if all three conditions are met for both population parameters. And so again, when we talk normality, those same things that we've dealt with over the last three chapters are going to carry forward again. So if you haven't gotten it figured out by now, if you're still making mistakes, you have another opportunity to redeem yourself here. All right. So for the mean, again, it's either going to be stated as normal, or we're going to have a large sample size so we can apply the central limit theorem. If neither of those two are met, then we're going to check the graphs. And again, we want to look at the NPP to see whether or not it's linear, and then we want to look at the box plot to determine whether or not there are outliers. And for a proportion, again, n times p and n times 1 minus p both have to be greater than or equal to 10. So those are the conditions that we're going to look for. Again, not a major change, just the fact that we're doing it twice. And then in the calculation step, obviously the name of the test is going to be different, and our test statistic, how we calculate that, will change slightly. It will follow the same general pattern as what we've seen in chapters 10, 11, and 12, but again, in general, it's going to be just slightly different. And then, of course, we're going to determine a p-value, and as always, we'll have that interpretation to reject or not reject. And I actually should make the comment as well, since we're going to deal with both significance tests and confidence intervals, the interpretation statement will also deal with that. We are blank % confident, blah, blah, blah. All right? So, again, a lot of carryover from the chapters that we've just kind of been working through the last month and a half, really. So if you haven't figured those concepts up by now, again, we're going to continue to hit on those, and hopefully we get these things figured out as we go. All right? So let's break down this idea of our parameter step just a little bit further. So let's go back to our cartoon that we started the presentation with. All right? If we were going to do our parameter step, and I just want to illustrate this so we can begin to kind of get an idea of what this will look like. Again, the first thing that we're going to have to do is define both population values. All right. Now, we need to be able to keep them separate, and you kind of have a couple of different options as to how you want to define mu. So we could say mu sub 1, or a lot of times what I like to do is use a letter that's kind of related to the problem. So here it's just said that the average woman, so we could say, okay, our first population, well, that's going to be mu sub w. All right. And so again, you don't have to use both of these symbols. You'll have the opportunity which one you can choose which one you want to use. I like to use the letters a lot just to keep it separate. All right, but in this case, this would be representing the average woman's salary. And then we have to define a second population. So we could say mu sub 2, or again, I like to use letters. So in this case, we'll be talking about men. So I'd put mu sub m, which would be representing the average man's salary. Right, so not a major change, but just the fact that we've got two values that we are defining in that parameter step. And then, of course, we're going to want to write our hypotheses. And so if we were talking about a null hypothesis, now in the past what we've done is we've said, okay, we're going to have one hypothesis that's equal to some number, right? That was our one sample data. Well, now we're not going to compare it to a number, but again, we're comparing it to another population value. And so again, the null hypothesis will still follow that same idea of being a statement of equality, but now it's a statement of equality between the two populations. So my null hypothesis would be that the mu of w is equal to the mu sub m. All right, so we're writing that hypothesis. We're going to assume that they're equal, and then we'll kind of take the statement in the cartoon that says that women is paid less than men. So that would be our alternative hypothesis. So H sub A would be that mu sub W is less than mu sub M. And so that's what our hypotheses are going to look like. Really not a major change, but this is the way that we'll write those. All right. Now I do want to talk about one other way that you can write your hypotheses as well. So as we write our hypotheses, there's actually two different ways that we can look at it. All right. One is similar to how we just wrote our hypotheses on the last slide, right? So that's how we wrote them on the last slide. We had our null hypothesis was a statement of equality. Our alternative was that statement of inequality, and just a statement of equality between the two populations, okay? Now the reason why I'm going to write it that way is because this is how it actually looks on your graphing calculator. So this is the most common way that we're going to write our two sample hypotheses. But another way that you could write them is we could think of them as a statement of difference. And this is going to be helpful when we work with confidence intervals and kind of interpret those and compare those to the conclusion that we make through our significance test. So again, this side is going to be the way that we write our hypotheses most often, but I do want you to know in the back of your mind, this is another way that we could write those, okay? And really all we're doing is subtracting mu sub 2 to the other side, and we're still creating this same statement. So instead of saying mu sub 1 equals mu sub 2, we say mu sub 1 minus mu sub 2 equals 0, right? Well, again, these null hypotheses are saying the same thing, because the only way we could subtract them and have it equal 0 is if the two values are equal. And then same thing here on our alternative, right? Mu sub 1 being less than mu sub 2, greater than 0. Well, that's only going to happen if mu sub 1 is greater than mu sub 2. So it's just another way to look at our hypotheses, this idea of a statement of difference. But again, that's going to be the number that we look for within a confidence interval, is whether or not the confidence interval includes 0, okay? So we want to keep this type of hypothesis in the back of our mind as well. Well, that brings us to the end of our Chapter 13 introduction video. Pretty short and sweet today. Again, I think you guys are going to pick up on these concepts pretty easily, but as always, I want to encourage you to complete the form below. The items that you guys leave in that comment box really does help me guide the lessons and the things that we're going to talk within class. And so I hope for those of you who have been leaving questions that you feel those are getting answered in class. I also want to encourage you to read pages 780 to 790. For those of you who watched the video pretty early in spring break, you know, it's almost going to be a week until we actually put these things into practice. And so the more that we kind of look at these in a different way, the more helpful it is to help us remember this information. So again, hope you guys have a great spring break, and we'll see you next week.
Made with DoodleCast Pro.